So the ArcGIS API for Python connects to your WebGIS, whether that is ArcGIS Online or ArcGIS Enterprise. You can do some administrative tasks like users, roles, group management. You can do some content publishing, whether you have some shape files,
Mute the voice on.
spatial analysis with imagery, with different location analytics and other tools that we have. It's a Python API, so you can write Python code, create applications, create scripts, and use notebooks to share workflows. But essentially, the Python API is just a Pythonic representation of your WebGIS. And without further ado, I'll be passing the control over to Andrew, who will walk through a little bit of visualization with the Python API.
So now we're going to dive into working with visualization. And visualization is the representation of information, and it can come in a whole bunch of forms. It can come in maybe an Excel spreadsheet or a diagram or pictures. And we're going to look at some of the common packages that can be used when working within Python ecosystem to visualize. The most common package for doing visualization is Matplotlib. This is considered a low-level API. That means you basically have access to everything, and sometimes it can be a little daunting to work with. So people have gone ahead and built convenience packages on top of Matplotlib. These include things like Pandas visualization libraries, Seaborn, ggplot, and Plotly. We're going to go ahead and take a look at these. For Matplotlib, it's a 2D plotting library, and it allows you to produce production quality images. It works in all kinds of environments. You can run Matplotlib and output images from Python scripts. You can use the IPython or Jupyter notebooks to view everything. People build web application servers to generate it. It's very robust. It can be installed using pip and condas, and it's been part of the ArcGIS ecosystem for quite a long time. Let's take a look at building a simple example. Because I'm in Jupyter Notebooks, I'm going to use what a percent matplotlib inline, and this is going to allow me to show my images directly in my cell after I run a bunch of code. I'm going to import some libraries, but the most important one here is to import matplotlib.pyplot as PLT. And I say as PLT because it's a shortcut form. And we're going to go ahead and create a stack plot with some fake data that I made. So in a few lines of code, I can set my labels. And then for each set of data, I can plot it quite easily, add a legend, put the upper left location, and show. The nice thing about Matplotlib and a lot of the libraries is that when it comes to doing specific input parameters, instead of saying absolute position like 0, 0, you can say words like upper left, so it makes it more intuitive to work with. And we'll see that as we go along. Pandas visualization is another part of the ecosystem, and it takes that Matplotlib framework and tries to make it easier. So let's go ahead and see a sample of this. We're going to create some information from NumPy. We're going to display it. This is going to be a cum-sum, so it's going to use cumulative summation over some random date times. We're going to create a date time range for 1,000 periods starting from the year 2000. And we can just get that stock market-like feel. So this gives the example if you were looking at a stock market and watching how the prices go up and down over time. Seaborn is another great library that I highly recommend you use. It allows you to, it's considered a high-level interface that sits on top of Matplotlib. You can find the documentation at seaborn.pydata.org. So we're going to import Seaborn as SNS and then also our matplotlib.pyplot as PLT. And Seaborn is going to allow us to set some convenience background colors and text colors by these styles that it has. So we're going to say seaborn.set style, my white grid. Now when we use Matplotlib or other Seaborn type charts, it'll auto format those for us. Let's go take a look. So we're going to create a scatter plot. And we took our data and we're able to plot it on the map. And notice with a few lines of code, we can set our hue, depth size, and our palette range, and we get this nice light blue to blue based on both the depth and the clarity of our diamonds that we got the data set from. Scatter plots, we're going to plot XY coordinate data on a Cartesian plane. So we can go ahead and we're going to use Matplotlib to do this and generate some random data, random colors, set our area size, and this is going to allow us to display our scatter plot. And we get our color range, random color range, and then also our XY coordinates. So they line up 1 to 1. We set our alpha, which is and then the size of each dot that we want. We can do the same thing with Seaborn. So we can take a data set as a whole, in this case a Pandas data frame, and then just set our columns to the X and Y, and then our hues. And let's take a look at this data set. It's slightly different. And we can see that we have survival rate for our scatter plot, and then also we also have it connecting the lines, so we can see for each point going up and down, and we can see the survival rate for males and females for our data set, where we have, if you're first class and male, you have about under a 40% chance to survive, but if you were third class and male, you're probably around 10%. Bar plots show comparison among discrete categories, and multiple libraries within the Python ecosystem show you how to do that. So we're going to do Matplotlib SPLT, specify each bar charts, our values, provide a legend so we know what we're looking at, label the x-axis by doing plt.x label, plt.y label. We can provide a title, and then we can show, notice that the first value, the default color for bar plots is blue. The second bar plot, we specified G, which is associated with green, and we see that in our plot. We can do the same thing with Seaborn. Once again, our data can be, we're going to use a preloaded data set from Seaborn that gives us our data back as a data frame. So in that case, we just have to specify the actual columns that we're going to want to work with. With histograms, they might look like bar plots, but really we're going to plot the frequency of distribution for the numeric data and splitting them into small bins. I'm going to do our imports and read some local data that I have in as a Pandas data frame. We can take a look at the data by doing dataframe.head, which gives the first 5 records. So we have XY data as well as various information associated with each data set. So we can plot it first using Matplotlib. We're going to do plt.histogram, pass in our X value data. We're going to tell it to auto size the bins. So if we don't know how we should be grouping this up, we're going to do it automatically. Set the color. Notice before when we did color, we specified G or B, but you can also pass in these hexadecimal codes. Set our alpha, so how much opacity you want, and then the width of each one. We can set our X and Y axis and our title. Then we go ahead and we can pass that information in. And then we can do the same thing. We can do a distribution plot within Seaborn, and all that stuff we did above, we can do it in one line of code. And notice we get a histogram with just one thing. So we see that Seaborn is that convenience on top of the other one. Pie charts is a classic way of showing information of composition of groups, but it's not a recommended visualization because the human eye is finds it very misleading. If you have to use pie charts, you should make sure that you do it in a proper form so you don't mislead your users with your user. So here's an example of doing a bad pie chart. So we have our pie chart vehicle class and it's bad. We can't tell what each of the values are for each one of these. What are we trying to emphasize within this one? Because our eye has trouble distinguishing, especially if we're trying to compare mid-size, pickup, and subcompact. Eyes have trouble distinguishing between the two. So if you are going to use a pie chart, you want to make sure that your pie chart has maybe things like the count for each slice, the percentage written out, and everything should be clearly labeled. Much like a a map where you want to have your title, your north arrow, a legend, all the maybe scale bar, other pieces of information to make a basic, decent map. There are some pieces of information that you want to ensure that every chart has, such as title, uh, the what each slice and color means, and then especially for pie charts, the percentages are very important because it's hard. For example, subcompact, which we're trying to emphasize here, which is 15%, it's very, very close to pickup, which is 14.1. And if you were looking at the previous one to this one, it was very hard to distinguish between the two colors. Data often overlaps, especially when dealing with XY coordinates. So we can do what's called a jitter plot to handle this case, where it's going to sort of shimmy the points left and right to show that there is quantity at those XY points. And then a heat map shows intensity of a value or concentration. So we're going to take some flight data that we have, and we're going to do Seaborn, and in one line of code, we can go ahead and plot that out. So we take our flight data and then our format, and we can plot it out. Years is the x-axis, months is the y, and the intensity is the number. Now you notice in this one, you also want to be careful with your colors when you're doing plotting, because with this one we didn't set our colors, and notice that it made the lower values more intense and the bigger values less intense. And if you're trying to, if your goal was to show low values, in these given months compared to higher values, then you're okay. But normally a higher value would be darker. So we can go ahead and we can also do this in Pandas, but once again, we can do our cool values to be our low values and our darker values to be our higher values, and it's probably more intuitive for a person to look at that. So when working with visualizations, it's important that you don't mislead your users. You have to realize that there's multiple ways of giving people that information, and you need to craft it for your needs. Now let's go ahead and take a look at some examples. So in this example, I'm going to go ahead and plot some COVID-19 data. I'm going to import matplotlib.pyplot as PLT. I'm going to use Seaborn, and I'm also going to import Pandas as PD. So let's go ahead and do that. Pandas has a convenience function called read CSV. It can read not only local data, but data from a URL. So I'm going to pull down this information from a GitHub website that has some updated information, and the data that I'm going to pull from is from May of 2020. I'm going to drop the columns I don't need, rename columns that are a little simpler, so from country, region to country, and then display the top 5 results so I get an idea of what we have. So we can see we have country, then the confirmed deaths, and covered and active for my date time range. I'm then going to take my data frame, group by that country code or country name, and then apply the aggregation statistics of summary. Let's go ahead and take a look. Now we can see for each country or country code that we get the total number of confirmed cases, deaths, recovered, and active for that region. I'm then going to sort the values by the number of confirmed cases and then get the top 5. Let's take a look at the top 5. We can see that the top 5, starting with number 1, is US with the large number of confirmed cases. And we can go ahead and instead of looking at the information in tabular format, we can take that data and we can visualize it. In this case, we're going to use a Seaborn bar plot for both the confirm and death and overlap them. So let's go ahead and take a look. So for the first bar that we put on our axis, we took the confirmed values, set the Y value to be the country, so in this case US, set a color, and then we labeled it to be confirmed for a legend. Then we did the same thing with recovered, with deaths, set our country, set the color to be a grayish black color, labeled it deaths, added some text to our maps, set the location for our legend, which would be the lower right, and then showed our figure. And now we have the number of confirmed cases and then plotted in black the number of deaths. So that's one way that we can take information and easily visualize it, and we can see where things are going right or wrong without having to dig through this table. Now, not all visualization needs to be in the form of graphs or bar charts or pie charts. It can also involve working with maps. So let's take a look at a demo where we take information that we gathered using the COVID-19 data provided by the New York Times. And let's look at some of this information both in the form of figures and also with maps to find who's maybe doing the best job or the worst job. So I'm going to import pandas and then import the ArcGIS API for Python. So I'm going to do import pandas as PD and then from arcgis.gis import GIS. I'm going to go ahead and read the CSV file and make sure that I set the county FIPS code to string as I import the data so it doesn't drop the zeros. We're going to do tf.head read and we can see that we get our information and the zeros are maintained. For each county code, we have survey data of how frequently people wear masks within each of those counties. Let's aggregate that information together and see how everybody's wearing their masks. So we're going to take the average of each column and then multiply by each one by 100 and then plot the bar chart. We can see that under 10% say they never or rarely wear a mask when they go out, which is good. We want to have that number as low as possible to help prevent the spread. And then always is over 50%. So let's go ahead and look at this information spatially. So I'm going to connect to my GIS using a profile. So GIS profile equals your online profile. I'm going to connect to ArcGIS Online. I'm going to go ahead and I'm going to get some county layer, query it, and pull it down as a spatially enabled data frame. I'm then going to go ahead and merge this information from above the table with the county FIPS on the FIPS code and then query out information to get the area where we want to target the most because they have the lowest number of people that wear the mask. I'm going to pass my query in, which is going to give us a row or rows, make a copy of it, and then now I have my worst area or areas. We can go ahead and take a look at what the area looks like, though that doesn't really give us any information because it's on a map. It's not on a map, and there's no spatial context. But let's go ahead and look at the worst single area. So we can do worst df.spatial.plot. This is going to create a web map for us. We can see that we're in Utah, and the area shows there. To get information about that area, we can see that it's Millard County in Utah, and almost 43% of the people never wear a mask in that area. So we can take the opposite of this. We can always say who's always wearing their mask, and we can get that information as well. So we're going to create our query. So we're going to say, masks that when they always go out, what's the highest value? Pass that query into our data frame to get back our row or rows, and then plot it. We can see that it comes back with 1, and then we can see who it is, and it's Inyo County in California. We saw we could see just individual geometries on the map for both the best and the worst. But let's say we want to look at the USA as a whole. And we want to look at the positive aspect of COVID-19 and people doing what's right. So let's go ahead and create a new column on the fly. We're going to call it combined. And within this one, we're going to combine both frequently always wearing masks and always wearing masks. And we're going to multiply it by 100. We're going to add it to a new column called combined. Now we can go ahead and plot the maps. I want to do a class break render, and I'm going to set the count to 5. I'm going to set that combined column that we created on the fly in our in-memory spatially enabled data frame. I want the values to be cool warm. So now we're using that same color map we used with the heat map when we looked at the flight data from the previous example and applying it to map. Setting the alpha to 0.7. I want the line width to be small because I really want to emphasize those locations and we don't want them to take up a lot of real estate when we look at it. I'm going to set my base map to dark gray vector, and I'm going to set my legend to true and then display the map. All right. Notice a few things. You notice that our map actually zoomed to the area of the United States, and we have data in both Alaska and Hawaii, so we zoomed out, but let's zoom into the continental United States. Our area that we're interested in, remember, the bigger the value, the more intense it is, and that's where people are wearing masks at a highly a very frequent rate. Areas in red are good. Areas in blue, you can see from the chart, have a low amount of individuals wearing masks. We can go ahead and interact with our map. And because we're using data that has more than just those columns we had, we pulled that information in from the Living Atlas, the county data. We get all the population statistics, and then we get our combined value. So 28% of people are always or frequently wearing masks. And we can see that never wearing masks is 0.3 or 30%. So we can use maps like this and persist them out to our GIS, provide it off to stakeholders, and they can have a quick way to see how we're doing across the country or how in tune the population is with the seriousness of the pandemic event that's going on.
Now we are going to do some COVID data visualization and analysis. So as always, we import the necessary libraries that we need. We make a connection to ArcGIS. In this case, I'll be using my ArcGIS Online account. And then we're going to download the data that we're going to be using. This data comes from ourworldindata.org. I'll show you that webpage now. It essentially just has a lot of different data from COVID-19, including data of up to date for each country and their cases, the new rate, the death rate, a lot of things like that. So I've downloaded it, and as you can see here, I have that COVID data.csv in my local directory. I'm going to use Pandas to read in the CSV, display the top 5 columns in it. So you can see a little bit what the data looks like here. You've got, in this case, we're all looking at just Afghanistan, but you've got the location, the date, the new cases, the total deaths, and some of these numbers also per capita, or per million, I guess, in this case is how they do it. So as you may notice, inside of this column, there is just the location string. There isn't any actual coordinates with that. So one thing I'm going to do is use the geocoding function to take that country's name and then get some different XY coordinates to write back to our data frame so that way we can properly visualize that on the map. So this takes a little bit of time, but once it finishes, we'll be able to have for Afghanistan point XY, whatever that is, for the United States point XY, whatever that is. So to give you a little bit of look, that just finished. So now I'm going to go through all of the different geocoded locations that I have, and I'm going to draw them all on the map. So you can see here, this is being populated, 1 point per country, just in the center of the country, as you can see. So now that we have all of that, let's actually add our shape column to our data frame, and let's write the appropriate coordinate location to the corresponding country inside of that data frame. Perfect. So now that we have all that, let's take, let's look at a certain date. So that way we're not looking at all the data and getting overwhelmed. So here I've just got the date for yesterday at the time when I'm writing this. Yesterday was February 1st. I'm going to take that data frame and I'm going to query it for only when the dates were yesterday for February 1st, and take that data frame and look at it. By the time you're watching this video, it will be past February, so just keep that in mind that I'm looking at the data from today, February 2nd, to looking at yesterday's data, February 1st. So as you can see here, I have points from Afghanistan, Albania, Algeria, all the different countries. It's just alphabetical. I have new cases, new deaths, and some of these numbers associated by the millions, as well as the shape column you see here, which is the actual point that we care about. All right, so we have all of these points into our actual data frame. So now let's plot it by using the spatially enabled data frame to plot a certain point. So now we have all those points that we saw before, but we are able to click on each point and see all of the associated information with that. So I can see here the total cases, new cases, total deaths, new deaths, etc. So we were able to take our data from a public location. We were able to read it in using Pandas, geocode some of the spots, and put it out on a map. But this is a visualization talk, so this wouldn't be complete if we didn't have nice ways to visualize the data. We're going to be using color ramps or color maps for this, so that way we can use different colors to represent different severity of COVID cases. I normally like to do the red, yellow, and green color ramp, which is somewhere here. This essentially works sort of like a stoplight, where green is good and red is bad. That tends to be the sort of standard that works for some people and that I personally like. So we're going to take all those cases from yesterday and we're going to plot them by using the classify natural breaks renderer. And we're going to look at just the new cases per million, so normalized per population, using this color map. So as you can see here, relative to other countries, darker green countries have lower new cases per million, and yellow to red countries have higher cases. So we can see the United States is a bit of a lighter green compared to some of the darker greens. And Spain is, as of February 1st, one of the countries with a higher new cases per million. It has 1,700 new cases per million, whereas we'll take an example of the United Kingdom has only 200. So that's why that point is red on there. And you can look at some other points from there. So with all that in mind, I'm going to just create a simple function that takes in a number of days ago and a certain column we care about so we can kind of gain some insight into the time component of COVID. COVID is rapidly changing and affecting countries in different times. So we're going to talk about the visualization of that. So I have this function that I've just defined, and I'm going to now say I want to visualize 30 days ago the new cases per million. So I call this function. And now, as you can see, this is for January 3rd. Spain, which is actually a little bit lower at this certain point in day for new cases per million. But at this time, the United Kingdom and Ireland were both being hit pretty hard for the new cases per million. As you can see, 800 for the UK, whereas Spain has 0 in that case. So that's pretty good for that. So now we can modify this and sort of gain insight into this from 90 days ago. Take a look at what the trends were then, right? As you can see, it looks like some other countries were getting hit pretty hard for new cases per million. You also can, using this function that I wrote, look at different columns. So in this case, let's not look at new cases, let's look at total deaths per million just from yesterday. So now we're looking at February 2nd, as you can see. And now when you look at the whole world, not just per day, not adjusted per, actually this is adjusted per million, excuse me. So this is normalized for the population. As you can see, the United States is higher for this with their new cases, total deaths per million, which would be here, we're at around 1,300. You can compare that to some other countries. Belgium is having apparently a higher amount of total deaths per million. They're at around 1,800, and other countries are doing a little bit better according to this data set. So that's per million. You can look back, that was for February 1st. You can look back in October of 2020 to gain some other insight. So as you can see, this is just a good way to gain insight into your days ago and the different column that you're looking at. You can take all of this information that you have from one of these points in time and you can save it to a web map that you see here. So now this has been persisted to my organization and we'll give it a second to load. I can now look at that, keep that in time and send this off to somebody. So the one point in time was able to be persisted to my portal like that. But this is only really a sort of blunt force solution with looking at the number of days ago and just looking at that. I want to have more of a dynamic solution where I can, in real time, look at some of the different time frames. So we can use that using the time slider property of the map widget. and making sure that our underlying hosted feature service, in this case, we would have published it, make sure the time aware, it is the time info is enabled and that you can gain insight into that date column that we saw before. In this case, I'm going to show you something different. I'm going to show you a class size renderer. So instead of the color changing, the size will change. And we're just going to look at a subset of data for the 2021 so far as of February 2nd. So as you can see here, this is now a class size renderer. So the size of the bubble is proportionate to the new cases per million as per this data set. But the important part about this is that you can actually use this time slider widget here. Let's get a nice subset for us to look at. And you actually can drag it and see how the time changes in real time. So this is one of the useful features of the map widget inside of the Python API, that you can sort of have that underlying data get queried by the time info, specify different time ranges, and see the changes in a more interactive way instead of calling that function all the time. You can do that for different columns. In this case, the last one was for new cases per million. Now we're going to do new deaths per million. So let's go here. And then you're also able to see that for this last month. And the cool part about some of this visualization part is that was just for the new year of 2021. But you actually can take all of the data that we have from COVID, and it takes a little while to load, but once it loads fully, you actually can look at the overarching total number of cases, so not normalized per population, and you can look at the sort of growth over time as the disease has spread all across the world. So a lot of different ways you can look at time as a function of your data, which I think is a very useful way for you to gain richer insights into your data, is not just looking at the numerical values, but looking at how functions change over time and how the data changes over time. So now we're going to switch gears from the COVID data, and we're going to go in a little bit more in depth on the map widget and some more complicated workflows for visualization. Everything we showed you so far has been a synchronous workflow. You run the Python, you press enter, the Python code runs and updates the map. One of the useful things about the Python API map widget is you can actually have callbacks and asynchronous workflows. So in this simple example, I set up a callback function that whenever I click anywhere on the map, I actually do a reverse geocode on the geometry and I print out that location. So this way, instead of running analysis by typing it out and pressing enter, I can just click on the map and asynchronously run that Python code to do that reverse geocode for different parts of San Diego in this case. So as you can see, this is a very useful workflow for being able to look at things on the map, click and drag, and then have the Python code run automatically on your clicking and dragging on the map. One thing else I want to show you is 3D mapping. All the maps we've done so far have been two-dimensional, but the Python API has a three-dimensional visualization mode. You can pan and zoom just like you would in any 3D scene. So zooming and panning and moving around, you can see these values of zoom, tilt, and heading all changing. So that can be a useful way for you to visualize some data, and you can switch back and forth between two-dimensional and three-dimensional by clicking on this button right here. So one of my favorite data to analyze for three-dimensional mapping is hurricane data. This is what it looks like in 2D, and it's an okay visualization of hurricane tracks going through the Atlantic, but I really like looking at the globe and even doing some sort of visual variable analysis on the different data points that we have. So I'm going to create a three-dimensional map, and I am going to actually tell this map, I want you to change the pressure, the color associated with the pressure. So for low pressures, I want red. For high pressures, I want blue. And for the wind speed, I want you to actually change the size of that marker. So of a low wind speed, have a low size, and of a high wind speed, have a high size. This is a really neat way for you to visualize all of the data in three-dimensional, but also look at two things at the same time. You can see the red from the blue is the pressure. So you can see here we have a high pressure point, and it's also a relatively tall point, so you know it's a high wind speed point. So this is a good way for you to look at the correlation between pressure and wind speed, maybe look for some outliers of high pressure, low wind speed, whatever you look at. But I think that 3D mapping is a great way to visualize different data sources when you're doing your mapping and visualization with the Python API. So that's all the time that we have for today. I'd like to thank you very much for coming to our session. And yeah, Andrew and I wish you guys the best rest of the day. And thank you again for coming to our session. Bye-bye.
Welcome everyone. Thank you for watching our session today. This is Bill Major. I am the moderator of this session. I'm joined by Andrew, who was one of the presenters of this. And I'm going to turn it over to Andrew now. We got some good questions that have come in that we're going to talk to now. So Andrew, take it away with, I know we've answered some by directly replying to your messages, but we're going to go through some of them verbally as well. So Andrew, over to you for a bit.
Great, thanks, Bill. And thank you everybody for attending, and thanks for all your great questions. So the first question I want to answer is, would we share the notebooks? And we are going to share the notebooks. We have a GitHub page on the, so github.com/Esri/ArcGIS-Python-API. And there you'll be able to find not just this conference's presentations, but going back multiple years. I think we have about 5 years worth of presentations on there that you can download, play through, and see how the API has actually evolved as time has gone on. It's really a valuable resource for anybody who wants to understand how the ArcGIS API Python works and see what all the new features are all the time. And it's also a great way where you can come out and talk to the developers. I'm the lead developer. Bill is a part of that as well. As well as asking all your questions to maybe the R&D team for ArcGIS Learn. We're all on there, we check it constantly, and it's a great way that you can talk directly to people who make these products, like myself. All right, the next question I want to talk about is, the question was about how I was running the code, and it says, are you using Jupyter Notebook or ArcGIS Notebook? And it says that they tried using Matplotlib with an ArcGIS Notebook in Pro, and it didn't work. The same code works in Jupyter Notebook. Everything I ran is a variation of Jupyter Notebook. Some was run in the ArcGIS Notebook server product that we have, and some of it was run locally with the on my own local Jupyter Notebook. I flip-flop between the two just because what I chopped up my demo in sessions, and some just made sense to do it local and some meant to do it on the server. But that's usually how I show code. And that also doesn't mean that you can only run the ArcGIS API for Python within Jupyter Notebook. This is like any Python package, you can run it through straight Python scripts. It can be run at the command line. It can be run, you can create geoprocessing tools and reference these scripts as well. So you have the full power of the language of Python. You're not limited to one development environment. So it's very important to understand that. The next question was about, we use geocoding within our demos that we showed today. And the question is, will the geocode function within the notebooks consume credits? And the answer is yes. In these demos, they did consume credits. It consumed a limited number of credits. The exact number, I forget off the top of my head, but it was very little. So when our notebooks are posted and you want to perform the geocoding operations, if you wanted to step through the code that Dave and myself did, you would potentially consume some credits, unless you had your own enterprise and you had your own locator service that you were posting against.
I was just going to ask you that, Andrew. I guess it depends on how your enterprise geocoder is configured. I guess if you had your own local geocode service or the geocode appliance, then as part of just the enterprise install, you wouldn't be charged credits because you're not reaching out to ArcGIS Online to geocode. But if you are using online to do that geocoding, then you'll be charged credits. Is that a fair statement? Okay.
Yeah, that's a very true statement.
Okay.
Sure. All right, the next question comes from Anonymous. It says, what do you need to import to use the SEDF spatial.plot, geoaccessor, geoseries accessor, the whole ArcGIS package? So there's three things you need to import when you're going to use the accessor and have it be put in. So accessors have to be registered when Pandas imports. That means Pandas has to be imported first, and the standard way you would do that would be import Pandas as PD. That's become the community standard for these libraries. The next thing you'd have to import is, at minimum, would be the geo accessor class and the geo series class. You can get away with just importing the geo accessor class, but you wouldn't have access to the rich geometry operations that are needed and the geometry data type that's needed in order to do the visualization. But you can still register the spatial without doing the actual series object, but they should be imported together. We got another great question, and this is about plotting once again. And the question comes about is, do we need to define a GIS in order to plot? And the answer is no. It will, if a GIS is not provided and you call stf.spatial.plot by itself, it'll go ahead and define an anonymous GIS for you and use that in order to get the JavaScript, underlying JavaScript libraries underneath. So that's that. Sorry, my filter went away. So we had a question here about the spatial enabled data frame again. And the question is, can I write the spatial enabled data frame to an in-memory feature class using the toFeature class? You can write to in-memory or memory. So if you use the memory workspace, you need to have Pro because memory doesn't exist in the ArcMap, well, workspace. So you need to have Pro available in order to write to that memory workspace. We had a question regarding color ramps. So you saw that the ArcGIS API for Python had a large collection of color ramps that are predefined. And the question was about color brewer. I haven't considered color brewer palettes, but that is a good addition. So it's something we're gonna take a look at. And hopefully we can get it in future releases. And once again, I encourage you to go to the GitHub page and to go ahead and, if you have ideas that can help improve the product or questions, please report it. Question that came in was, is an ArcGIS license required to use GeoAccessor or the GeoSeries libraries? And I assume by license, you mean ArcGIS Pro. You do not need ArcGIS Pro to use the spatial enabled data frame. You could actually leverage the spatial enabled data frame with Shapely and Fiona to do reading and writing of information. So there you would need PyShape, Shapely, and Fiona in order to be able to read and write to file geodatabases, write to shape files. And Shapely would be your geometry engine, but it works well with the open source libraries that are out there. We had a question regarding the being able to set the time function on the widget. And on the map view object itself, there's a property called time mode. And this allows you to define your temporal data and display cumulatively over the point in time. And you can also set your start time and end time for those windows. And then there's also a property on the map widget called time slider, which is a Boolean, and it's a getter or setter. And if you set it to true, the time slider will display on that widget. Okay. We have time for a few more questions if anybody has them. Give about 30 seconds. Oh, we have another question. So how easy is it to convert to different libraries to be in the ArcGIS map, for example, Folium or PyVis maps? It really depends on the library they're going to. So if it accepts our data structure, it's fairly easy. If not, you'd have to convert it to whatever they need for to do their geometry representations. whether it's, if you're doing like polygons, for example, and you want to display it in a Matplotlib map, you'd have to convert it to patches. So it has to fit. There's no direct conversion. You'd have to create that translator.
Hey, Andrew, I'm just starting a message here. The GitHub URL, if you could reply that URL to that chat there so a lot of people can see it.
Sure. So if you look at that question, I'm going to put that in right now. This is our public GitHub page, github.com/Esri/ArcGIS-Python-API. And if you have any issues, I actually pasted the issue link in there, but that'll take you to it. And you can find the conferences, log an issue, talk, ask questions. Like I said before, it's really going to be a great way for you to, get familiar with the API on top of using the developer help page as well and the API reference. Okay. All right, well, I want to take this time and say thank you for everybody for coming. On behalf of Bill and myself, I really appreciate everybody who came out to watch our presentation and asked all these wonderful questions. If we didn't get to your question, we'll do our best to get back to you if you signed in. And I encourage you to go to our GitHub page that we paste in the answer for the questions. If you have further questions about the API or anything else regarding the ArcGIS API for Python. I hope you all have a wonderful day and a wonderful rest of your conference. Have a good day.